So let's look at an extremely important area with inside technology, and that's security information and event management. And what we'll see is that SIEM is the move towards big data analysis, where we can take disparate data logs and then aggregate them into a single analysis, and then use a free-form analysis to find trends and so on. And really, what we're seeing is a massive increase in the amount of data that we have on the internet and with inside systems. 12 terabytes of tweets every day, 90% of all the data being produced in the cloud in the last 2 years, and 2.5 quintillion bytes, that's a billion hard disks of data produced every single day. And really this trend is because all of our industries are moving towards a data infrastructure, banking, oil and gas, e-commerce and so on. And the infrastructure that we created for data is now being scaled into voice, video and also into sensors. So we have an increasing amount of data, and what we'll see is that the data that we collect from security information devices can be used for a whole range of analytics. And we see in the media every single day that big data is playing an increasing part of businesses, and people like data scientists will become the new rock stars of the future, as we take more and more data and we use it to analyze how best to run our businesses. There are 4 V's to big data. The first one is velocity, and with velocity we analyze the speed of the generation of the data, how quickly is it being generated. Then we have veracity, and veracity is how trustworthy is the data that we get. So the data from a switch might be highly trustworthy, where the data generated from users might not be. Then we have variety, and that's the different forms that the data might be in terms of syslogs or Cisco logs or event logs, and even environmental logging logs. And then there is volume, the last V, which is the scale of the data, the amount of data that's actually created. And then from this we can produce a whole range of things such as management reports, sales analysis, targeted marketing. We can look at trends, and we look at how disparate data sources can help us identify possible causes of problems inside our infrastructure. And we can see the increasing power of computers. In 1997, Deep Blue beat Kasparov using a clustered machine. And then in 2011, Watson beat the humans at Jeopardy. And then recently, Watson, the IBM Watson computer, took disparate data sources and brought them together to beat the best cancer specialists in the world. So we can see how data has been used more and more within high-performance computing environments. So let's look at SIEM and what SIEM actually is. So why does any company invest in security and continue to invest? Well, there is obviously a requirement to protect users on the system from abuse, either from external threats or also from internal threats. So we have things like virus scanners, email, spam filters and so on. Really to protect users from malicious activities. Then we need to protect our assets. They may be our servers, our network cables, our wireless systems and so on. And increasingly this is a key important asset for many companies, and even involves things like protecting electrical supplies, making sure there's generators and so on. Then companies often have to protect their intellectual property and the data that they gather from systems and for their customers. So there needs to be some protection of the data. And then often there is some audit compliance reason why a company has to comply with a certain audit compliance regulation, such as Pci Dss, in order for them to do business. The company will also have to protect any transactions that are undertaken and then be able to detect fraud if they're an e-commerce company. But two important things for a CEO is often the customer trust. A security incident can reduce the customer trust in a company, and there's also shareholder trust, where a security incident could cause problems for the value of shares in a company. Okay, so this is what we've looked at before, and this is our penetration testing methodology. We have a standard taxonomy for actually defining a risk, a threat, an asset, and a vulnerability. So why do we actually go ahead and do our penetration testing? Well, we often want to investigate our CIA, our confidentiality, make sure that our data is kept confidential. We have VPN access, passwords, and so on. We need to make sure that we have integrity for our systems. We have checksums and file protection systems and so on, and access controls. And then availability is becoming a key part of our assessment, where we have failover equipment and mirror servers and so on. The reason that we often do this is because of some audit compliance reason, and these are some of the US audit compliance laws that companies often have to comply with. So a company which is dealing within the healthcare industry often has to comply with HIPAA regulations. And if they trade in the US, Canada or France, they must abide by Sarbanes-Oxley's for their reporting and so on. So these are often the reasons that companies will actually implement security testing infrastructure. And this is what can go wrong. So we can see problems with certain companies. In this case, Adobe, there was 150 million user accounts compromised. The top password was 123456, which had a hash of this, which was fairly easy to break. Nearly 2 million users actually had that password. Next most popular, 1234567889, and so on. And we've seen many breaches of security, such as the Sony hack, Sony PlayStation hack, LinkedIn, and so on. So it's important that companies are continually testing their infrastructure and their systems to make sure that they comply with regulations, but also that they protect user accounts. One of the most important inside an e-commerce type environment is the Pci Dss, and so companies must be compliant with this to be able to trade for e-commerce. With this, the company must make sure that they build and maintain a secure network that's looking after the firewalls, have good system passwords and so on. They should always make sure that they have some sort of vulnerability management, where they're defining updates to their virus and maintaining all their systems with patches and making sure that applications are up to date and secure. Then there is a strong access control requirements inside the Pci Dss, and with that we restrict access to cardholder detail and make sure that every user has a unique ID and all the accesses to sensitive data is actually logged. And of course there must be restricted physical access to the systems. Then there must be a policy which is defined and implemented and audited against for the whole system. There should be some monitoring and penetration testing of the infrastructure, and of course all the user data, the cardholder data, should be stored and encrypted. So we can see this is a major challenge to make sure that if we deal with e-commerce, then we need to make sure that all these things are correctly implemented. Another audit compliance regulation is Sarbanes-Oxley's, and this was brought in because of the frauds that was faced with Enron and WorldCom and so on, and it was brought into practice through these two senators, but it's now been applied into many countries of the world, including Canada and France. And really it focuses on making sure that fraud can be detected at an early stage. There's an oversight board, there's an analysis of any conflicts of interest. If someone is on a company and then there is sales transactions to another company of which they are also on a board, then that can be called into question. There's auditor independence to make sure that auditors come in and make sure they do their job correctly. There's corporate returns, and there's a corporate responsibility part. So what do we focus on when we're looking at SIEM? Well, the main thing is that we're taking our logs from many different systems, many different sources, from routers and switches, intrusion detection systems, lots of different servers, from the host machines, and so on. And they might be in different forms, or most likely they'll be in different formats, but increasingly they're becoming a flat format where it's just really log information which is stored in some sort of comma-separated format or in some non-structured format. Then what we must do is we must correlate these logs to bring together events, typically on a timeline, to take each event and then to plot it as a timeline to see when things caused other things and then what things are correlated to other things. An important part of SIEM is to make sure that the dashboard is working correctly and is aggregating data and showing the information that the user can actually interpret to find out what is happening on the system. So for a security analyst, they might be looking at network traffic and seeing any spikes or dips. For a business analyst, they might be looking at the amount of successful transactions on a website against the number of unsuccessful ones. And for an overall manager, it might be a checkbox to make sure that the systems are all working correctly and there is a good throughput of transactions. So the dashboard is very important to be able to present information. And we'll see a good dashboard later on. Often they're a very simple dashboard with traffic lights, nice colours and graphs and so on. Then there is normally a reason why the login has happened, either to detect security events or to comply with a certain regulation. So this is where we can gather the correct information required from our system and make sure that we can integrate these into audit compliance reports, such as for Pci Dss. Then there is a retention of the data. We might need to keep data for a certain amount of time for audit compliance reasons, or if we are attacked, we might have to trace back our data into the past. Then there is some sort of forensics analysis that we might do. If we've been attacked, we might have to analyse it from a forensics point of view. So what do some of the systems actually look like? Well, we can take data from lots of different places around the system. We could take it from a syslog, that's for TCP, UDP packets and ports. We can take it from the host logs, this is the application security system logs. We can take it from files and directories for create, read, update and delete access and any security changes there are. We can look at the performance. One place often to look when there's a security incident is that the CPU often goes very high on a system. So for denial of service, you might see that a server is running at almost 100% because it's trying to cope with a great deal of traffic. But memory and threads and so on can also give us that information. Then there are logs for different systems, there's changes in registry keys, there's remote access logs for VPNs, there's print monitoring for jobs, there's email logs, intrusion detections, there's Active Directory integration, such as for user additions and host changes, and there's even environmental changes. So if we find that the temperature of a CPU or of a machine is increasing, it might be that there is a problem, it's overworked, or there's a problem with the air conditioning system. One thing that we often do is that each device often has a local memory for buffering. So in this case, this is a Cisco device, and with a Cisco device we can actually define that we're log, and we can log to a buffer, define the buffer size, and then we define the level of the logging. So in this case we can log from 0 to 7. This is the least amount of information, and this is the highest amount here. We would only really turn debugging on when we have a problem, such as with a VPN connection. So the higher the level here, the more that will actually be logged. You can see here we've just used emergency logs for that one. But often what we do is that we log not just to the local machine, but also to a syslog server. And the syslog server will store logs from across the network, so that when the buffer overflows on the device, we still have the syslog server to look at. Okay, so this is an example here using the Kiwi syslog service. So what we'll do is we'll just quickly have a look at what that looks like. So what we'll do is we'll run our syslog server, and just give you an example. Okay, so let's clear our syslog server here. Okay, the syslog server would normally be sitting on a network somewhere, and what we'll do is that we'll just go for snort. So in this case, very simple rule. What we've got is we just have an alert here. So we'll just say for any connections, we could go for port 80 here. So for any connections on port 80, we're actually going to output it to a syslog server. We can put in the host address and the port, but we normally default to port 514 in terms of a syslog server. So if we go with that, and we'll just save them. And now what we'll do is that we'll just run with our rules, and I only have one network connection here. Okay, so we'll just run that. And there we go. Okay, so we can see the syslog server is storing the access is here there. And then from here we can actually integrate that into our SIEM infrastructure. Okay, so we'll just quit that. Okay, so really we can have lots of different logs aggregating into the syslogs, but we can also pick off logs from each of the devices. A key thing for us is to make sure our time zone and our time synchronization is set correctly. Okay, so let's look at the different types of SIEM that we can get and the types that you're likely to see when you go into industry. Okay, so this is the Gartner Quadrant of companies in the SIEM market. The companies up here are the ones who are the leaders, and also have the customer base to really push through their leadership. So we see up here ArcSight and the Q1 Labs IBM product. McAfee's up here, and then we'll have a look later at the Splunk package and Logarithm. So each of these are really doing very well in the market just now. The other ones obviously aren't quite leaders, or don't have the completeness of vision that we have here. So we're going to concentrate on this quadrant here for our analysis of each of the different types. Okay, so this is the Q1 radar, and this is the IBM product. And we'll see it produces a nice little dashboard here, and it's especially good at being able to collect information from Cisco devices. So a great feature of a Cisco device is the NetFlow feature. With this, we can actually gather information about traffic from a device and then send it to an agent to be able to pick that up. So here, you see, it's very good at actually collecting information about all the different type of network that's actually on the system, and then to be able to pick up any possible offences on the network. But you can see greatly it's influenced by network flow and network traffic. And the system that many of the devices use within SIEM is to be able to use Cisco devices with NetFlow actually installed. So this can normally be used on a device with iOS 12.3 and above. This is our basic configuration here. And then what we get is that we get our flow information, such as the amount of traffic for each of the protocols and the amount of flows that we have. For this, we can actually define either an ingress monitoring or an egress monitoring. Normally we define a UDP port for our collection agent from our devices. In this case, we've selected UDP port 999, and that's the destination that we have here. And this is us applying it onto the port. So let's have a little look at our device. Okay, so we'll just pull up GNS3. So I just select my device and start it, and then we'll just open up the console. Okay, so here we are. Okay, so we go into configuration mode, and then we should see that there should be a flow export command, and there it is there. Okay, so this is the command that we're actually going to use to be able to set up our flow analysis. Okay, so we can set up the version of it. In this case, it's version 9. We'll go for is the most up to date, and then what we'll do is that we'll now set up the destination. Okay, first with an IP address. Then with a port. Okay, so after we've done that, we then go into our interface. Okay, and again, we'll have a look, and it should be IP flow. There we are. And in this case, we can log on the ingress. And we can look at running configuration, and we should be able to see that we've actually enabled our flow on the ingress of EFA0, and here is our setup there for our flow control. Okay, so there's a number of commands that we can actually use. But IP cache flow will actually show us all the flows that we have between our devices and so on. Okay, so this is a very useful method to be able to capture our flows across our networked devices. The next one that we look at is the Logarithm System, and it's especially good at to be able to create different reports for different stakeholders, such as for IT operations, for information security, audit compliance, and executive management. It's also good at creating different types of reports for our audit compliance requirements. I can see here it's useful in a range of different environments for our virtual machines, our payments, and so on. Okay, this is an example output, but it's similar to what we've seen with the Q1 Labs output. One of the packages which really takes a different approach to SIEM is Splunk, and Splunk aims to capture logs from every source that's actually possible, and also to be able to integrate logs from external data sources that might not actually relate to the ones that are focused on security. So this is our basic infrastructure that we have, but there's a whole lot of different logs that we can pick up from Windows logs, Linux, virtualization, applications, databases, and so on. But it tries to really integrate a whole range of things. And these are some of the charts it produces. We can see here timelining and analysis and so on. But we'll see that it's almost an infinite amount of things that we can actually analyse with Splunk. And we'll have a look at Splunk a little bit later. First, we'll look at ArcSight. So with ArcSight, it's particularly good at integrating for audit compliance, and these are our devices that we have in there. But it will generally try to log across the network infrastructure. And that's a dashboard from it. We can see our events here, some sort of logging of activity, and then this gives us our overall dashboard focus. Okay, so let's have a look at the Splunk package. Okay, so we've set up a demo here in terms of the usage of Splunk. So what I'll do is I'll just log in as an admin. So obviously you can have different levels of logins. So I'll just log in as an admin here to be able to show you the basic logging methods that you can actually have. Okay, so you see very simple initial user interface, which is good. Then what we can do is we can add data. So if we have a log that we want to analyze, we could add it here. But let's see the range of inputs that we can have for our system. Okay, so here we have we can have local event logs. So I could enable an event log on my machine here or on the server, and then we could define things like CPU utilization. So we could look at the event log, and then from there we can actually interrogate the security log. Okay, so if we were interested in users logging in and logging out, we could log that. So that will now pick off from the security log. But you can see the amount of different data sources. We can do remote events, files and directories, TCP, UDP from syslog servers, as we've seen before. We can have Active Directory monitoring, and so on. So there's a whole lot of logs that we can actually gather in some sort of real time. But we can also add our data here if we wanted to. and it's at this point that we might be able to add Windows logs and so on. Okay, so you can see the range of data that we have. So just now we've added a number of logs to this. And let's try and find those logs first. Here we have them. Okay, so in this case what's been added is a security access log. And so this is from an Apache web server. Okay, that's what that looks like. Okay, so we can see here we log the IP address, the date, if it was a get or a post, and what the session was, the browser, and so on. We also have the security log in here. Okay, it's a bit difficult to see that from Notepad because it's a Linux log. What we'll do is we'll just have a look at that one too. Okay, so this will typically show us things like failed passwords and the username and so on. Okay, so that's what that one looks like. It also has the vendor sales log and also a mail server log. Okay, so that's what the mail server actually looks like. And so the great thing with Splunk is that we can actually very quickly search for data. So in this case, the main focus of this data is on Buttercup's games, which is the company. We can do a quick search to see anything that relates to Buttercup games. So in this case, we don't actually have any real structure to a data. We will generally search around. So this will show us the amount of times that Buttercup games was actually used with inside one of our logs here. But if we want, what we can do is that we can search. Okay, in this case we went for Macintosh and Buttercup games, so you can see there's a bit of a peak here. Then from that we can actually zoom in on a certain time of our logs. Okay, so you can see from there. And down here we can actually see all the things that are related to it. So if we were interested in any of these parameters, we could look at client IP addresses, and this shows us all the client IP addresses that relate to Macintosh, and also for our Buttercup games there, giving us a count in there. Okay, so all along it's really given us a lot of flexibility and to be able to analyze the logs. And so let's say we were interested in this IP address here. There we go. Okay, we can just zoom out. And we can actually see there was the activity related to that one machine actually there. Okay, so you can look for logins. See, in this case, let's see if we have any logins there. So this is of the log that we've actually just stored for a server, and we can look for unsuccessful. Okay, let's look back at our logs and we'll look for the word failed. And password. And what we can do is we can focus on a certain log. So in this case the source will come from our access logs. Anything with access star. Just put that first. So in this case we'll look for security. So there was nothing with inside the access. So we'll look at our security logs. Secure.log. And there we go there. Okay, so let's say that this is our log there. So what we could do is that we could actually see if we can find any times that root has been tried. And there it is there. Okay, so we can see that it looks like we had an intrusion. We could have had an intrusion here. So there was lots of attempts for root on all these, from all these different machines. So let's focus in on this machine here. And that's on our mail server then. And there we go. Okay, so we see quite a few events caused by someone logging in as root from this machine here. If we wanted, we could actually have a look at each of these and to be able to lock down on that. Okay, so the great thing is that we can focus on just one or two logs, or we can look across a whole range of logs. Okay, so this is if we want to go back to our web logs, we could just concentrate on them. Okay, so this is an example here where we look at the SSH daemon, where we get a failure or a failed login that we can then analyze from that. So the next one is that we're going to look at our access logs again. We're going to count the number of gets that we've got against the number of posts for our web accesses. Okay, so let's reset our date range. Okay, so we can see here that what we got was 24,866 gets and then 14,666 posts. Then we can actually have a look at the visualization of this. So this is on our server here. This is the number of gets, and this is the number of posts that we have. So the next one that we'll look at is in terms of the amount of time for a transaction. Okay, so this puts it into these bins. So this is the this is in terms of seconds that it took for a transaction, and then we can visualize it from there. Okay, so you can see there are problems here. There's quite a few that have taken a long time, and we could investigate those to determine why they actually happened. And one of the best things about Splunk is that it can actually be used as a proactive business tool. Purely from the business logs, we can actually start to pick off some useful business information. So this is shown, so for this, we're gathering together the sales. So this is a successful transaction, and the action was purchased. So when we look at the actual web log for the transaction, we see the word purchase there, and then this is going to order in terms of date and hour. So you can see here these are the sales for each of the different categories that we had. So in the sale itself, there's a category ID in there. Okay, so if we want to have a look, so the action is purchase. Okay, so action purchase is what we're actually looking at. And then there is an item ID. And the great thing about this is that we can now track through our security log what the sales of each of our products actually were. So you can see that our event logs are actually becoming an excellent way to be able to track our activity. Okay, so purely by looking at the actions and also the item that it relates to. So there's the category ID in there. So look, category ID, simulation. So what we're doing with this is whenever there's a purchase and there's a category ID, then that's what we're ordering them by. Okay, so there's a purchase. And then, okay, so let's look at the top category one. And there we go. So that's aggregating all our sales across purchases and then analysing it for that category ID. So you can see that's now giving us the total number of successful 200s with a purchase, and then for each of the categories. So it's automatically popped off the category ID, and then it's actually determined the number of times there was a 200 event there, and given us that back as a result. Okay, so here we are. If we can see our category ID, and there's arcade, simulation, and so on. Okay, so Splunk gives us a great great amount of information, and we can use that to analyze our systems purely from our event logs. Okay, so what we can then do is that we can create dashboards for different types of users. And let's say we wanted to do a dashboard for the sales. This is coming from our logs, and we quite liked this one. You can obviously vary for different times. And there we go. So we can have that updating in real time. We can add another panel in there for this one here. We'll go for this one. This one is our sales overall. And if we wanted, we could pick different times from there, but we'll take from all time. And there we go. Okay, so you see how great the package is for being able to very easily produce different types of dashboards, different ways of showing things. There's our scatter one. And we can very easily get our reports from there, and we can really focus them on the different types of analysis that we want to do. Okay, so that has shown us, given us an overview of SIEM.